This video is about reflections on a coordinate plane, and it's an extension of a more general video, which is mathematics, transformations, and reflections. So if you want a more general explanation, please watch that other video first. In this one, we're going to have an in-depth process about how to go about finding a reflected image using coordinates on a Cartesian plane. So the problem we're going to work through is reflecting the triangle with the vertices of -1, -2, -2, 1, and 0, 3 over the y equals x line. So the first thing we want to do in order to work this problem is to graph the vertices and the mirror line. This is going to make it a lot easier for us to kind of visualize what's going on. So we have -1, -2, -2, 1, and 0, 3. Now we can just connect those points to get our triangle. And we said we're going to reflect this across the y equals x line. So that is going to go about like that. If we go in the opposite direction, we'll have it about like that. So that's what our triangle and our line is going to look like. And let's go ahead and just label our points on our triangle so that we can talk about them later a little easier. So we have points A, B, and C. So the next step is going to be to find the equation of the line perpendicular to the mirror line. So the mirror line is at y equals x. And we want that line that we're finding to pass through the vertex using the point slope equation. So we're going to have three different lines here. So we're going to have, first, we need to come up with how to find this perpendicular line. Well, we know our mirror line is y equals x. And we know that for perpendicular lines, our slope is a negative reciprocal. So our slope of our mirror line is just 1. So our slope of our perpendicular line is going to be -1. So now that we know that, we can use point slope form in order to find our equations. So if we're looking at point A, we have our coordinate -1, -2. Well, point slope form says that we have y minus y1, so y minus a -2, which will just become +2, is going to equal m, our slope, in this case, which is -1, times x minus x1. Well, x1 is -1, so two minuses are going to become a plus. Now if we simply solve this, we'll see that we get y equals a -x minus 3. We're going to go through and do this for point B. Which has the coordinate of -2, 1. I'm just following the same steps as before, putting into point slope form and simplifying it. Same with point C. Now we have these perpendicular lines. So our next step is to solve the system containing the mirror line, which is y equals x, and our individual point lines that we just solved for, in order to find where those two lines intersect. And that's going to be where those perpendicular lines are going to kind of intersect our mirror, so we can see how they're going to reflect. So for line A, we know y equals negative x minus 3. Well, we know that in all intersections, y equals x because it's on that line. So we're going to substitute y equaling x. So in line A, we'll do our substitution and get x equals negative x minus 3. So we'll have 2x equals minus 3, and then x equals minus 1.5. Then from that we say, well, we know x is equal to y, so y is equal to negative 1.5. I'll repeat this for line B, which has the equation of y equals negative x minus 1. When we do that, we'll have x equals negative x minus 1, 2x equals minus 1, x equals minus 0.5, therefore y equals minus 0.5. For line C, do the same thing. We have our equation for line C to be y equals negative x plus 3. We do our substitution, we'll have x equals negative x plus 3. Add x to both sides, we'll get 2x equals 3, x equals 1.5, and then therefore y equals 1.5. So, now we have to go on to step 4, and that is determining the distance between a point on the mirror line and vertex. So, from now on, I'm only going to show calculations for point A just to save some space and time here. So in order to find the other mirror vertices to finish this reflections problem, you just need to do steps 4 and 5 for points B and C, just like we did for A. So we're going to find this distance. So for point A, we know we're going to find the distance then between points negative 1, negative 2, and where it intersects the mirror line, which is at negative 1.5, negative 1.5. So the distance for line A is going to be equal to the square root of negative 1 minus a negative 1.5 squared plus a negative 2 minus a negative 1.5 squared. Whenever we do that math, we'll see that distance of line A is going to be equal to the square root of 0.25 plus 0.25, which is just the square root of 0.5. Okay, so now we have this distance, and what this tells us is this tells us how far away our vertex is from that mirror line. We know our reflected vertex has to have the same distance. So we're going to set that distance equal to a distance equation and solve for our other mirror vertex. So we have point A that we're doing this for, and we know that that distance of A is going to be square root of 0.5, and we're setting that equal to another distance formula. And we don't know our x in this case, that's what we're going to solve for. So we have x minus a negative 1.5 squared plus a y minus a negative 1.5 squared. because remember we're using those 1.5s because we're looking at between the mirror line and the other vertice. So whenever we kind of want to simplify this, we can take the square roots off, just pretend we square each side. So you get 0.5 equals x minus a negative 1.5 squared plus y minus a negative 1.5 squared. So now we're going to do some substitution. We're going to substitute y equals negative x minus 3 into our equation. So we'll have 0.5 equals x plus 1.5 squared. We just changed two negatives to a plus there. Plus negative x minus 3 plus 1.5, all that squared. So now we just need to kind of expand all of this out. When we do that, we'll have 0.5 equals x squared plus 3x plus 2.25 plus x squared plus 3x plus 2.25. And whenever we combine like terms here, we're going to go and move this 0.5 over. We get 2x squared plus 6x plus 4. Using the quadratic formula, where we have b squared plus or minus the square root, or excuse me, just b, the square root of b squared minus 4ac, all divided by 2a, where a is going to equal 2, b equals 6, and c equals 4. Whenever we do this, we're going to get x equals a negative 1, or x equals a negative 2. Now we have two answers here because there are 2 points on this line that satisfy that. One is our original vertex and one is our mirror vertex. Well, we know that the negative 1 is going to be the one with our mirror or our original vertex. So this is going to be the x-coordinate of our mirror vertex. So whenever we substitute this into our equation, we have y equals negative x minus 3. If we substitute in the negative 2, we have y equals a negative 2 minus 3. And when we substitute, or when we solve this out, we'll have y equals a negative 1. So our mirror vertex of A is going to be at negative 2 comma negative 1. So that's how you can solve these types of problems. And like I said, if you want to find the full reflected image, you simply need to repeat this process in step 4 and 5 for points B and C.